Okay, it's finally time to do an example from start to finish. You've seen enough, you understand enough to understand the complete example. Now, in this case, we're given a truth table which has 16 rows, 4 variables. So right away, I know that I'm going to need to draw the biggest of the Karnaugh maps. So I've got my full-size Karnaugh map here. And I've got 4 variables. They won't always be A, B, C, and D, so keep your eyes on that. Just want to make sure that you keep the variables straight. I'm going to go ahead and number the cells. Okay, now I'm ready to begin to fill the table. So I'm going to break this into groups of 4. 1, 2, 3, 4. 1, 2, 3, 4. I have 1, 1, 0, 1. 1, 1, 0, 1. Then I have 1, 0, 0, 0. 1, 0, 0, 0. It wouldn't have made a difference there, but I'm always careful to do it in the correct order. 0, 1, 1, 1. Skip a column. 0, 1, 1, 1. 0, 0, 1, 0. 0, 0, 1, 0. Okay, that completes filling the table. Now it's time to begin to focus on grouping the table. Now this is kind of an interesting little pattern here. I might be tempted to draw cells 0 and 1 or cells 10 and 11, but I think that if I look at it long enough, I'll see that I want to group here, I want to group here, I want to group here, and I want to group here. I believe that that is the fewest and largest groups that will cover all of the 1s and cover none of the 0s. So I can see that there are 4 product terms here. Those 4 product terms are going to each lead to, there's 4 groupings which will each lead to a product term. So I'm going to go ahead and write my equation. F equals, I'll take them from top left to bottom right. So I can see that the first grouping here corresponds to C and D both being 0, and it corresponds to A being 0. So I have not A and not C and not D. Or, and then I'll remove those arrows, and then I can look at the cells 1 and 3. Well, those both belong to not A and not B. That's the first column. And then they also belong to D, because D is equal to 1 for the middle 2 rows. Then I have, let's take cells 9 and 11. That belongs to A and not B, and also D, because it is the middle 2 rows. And then I can say or, and then cells 10 and 14, those both belong to C and not D, and then they both also have A. So I have A and C and not D. So that is the optimized sum of products expression that can be used to implement this truth table. I was asked to draw the optimized circuit. Now I'm not going to do any factoring or any sort of additional improvement to it. So I'm going to see that there are going to be 4 AND gates. Those are all going to feed into an OR gate. I'm a big believer in drawing this second half of the circuit first, because right there, well, let me say, I know that each of these is going to have 3 inputs. If a student did this much work on the problem and got these parts correct, to me that's half credit for the circuit diagram, so that makes a big difference. I can see that I'm going to need A bar and A, so I'll have A here, and then I'll send it into an inverter to get A bar. And then I can see that I'm going to need C. Do I ever need C by itself? Yes, I do. So I'll have C bar, and then I'm going to have D bar. This is going to get pretty messy. I have not A, so I'm going to come down here, skip over, come into there. Not B. Oh, that's the first time I'm encountering B, so I need to invert it, and that'll go into there. And D. So I'm going to go ahead and grab D here, scoot in between there, come down and come into there. A and not B. Okay, well, A is here. Okay, and then not B, well, the closest place I can get not B is right there. And D, okay, D is right here. It really gets kind of painful to draw these circuit diagrams and even more painful to read them. And then A, well, the closest that I had A was right here, so I'm going to grab A right there, bring it into this input. And then I have C, yikes, C. How about I'm going to cheat and come around the outside there? You're not supposed to do that, but in this case, I think it's the best choice. And then I have not D. Well, not D is closest available here. So skip, 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 done. Probably at this point, it would be better to have an alternate way of drawing this where I would just perhaps have each of the variables drawn multiple times. So it would help to eliminate some of the spaghetti that's there on the left-hand side. But it's nonetheless a complete solution. We're able to go from the truth table to drawing the K-map, filling the K-map, grouping the K-map, writing the equation for the K-map, and then drawing the circuit diagram for that equation.